Our next lesson is on factoring trinomials and a general factoring review. A trinomial is a polynomial with 3 terms. That's what the tri in trinomial means, 3. We will first focus on trinomials with leading coefficient of 1 in the form x squared plus bx plus c. Notice that each one of these examples have a leading coefficient of 1. I call these trinomials easy trinomials, okay, with a leading coefficient of 1. Before we factor, we're going to first distribute the following and look for patterns. So if we go forwards, then hopefully maybe that'll help us to find patterns so that we are able to go backwards. So I'm going to distribute x squared plus 3x plus 2x plus 6, and then when I combine the two middle terms, I'm getting x squared plus 5x plus 6. I'm going to ask you to pause your video and do the next two on your own. Now that you have those worked out, let's look for any patterns we might see. If we start looking in the problem that I gave you, the x plus 2, x plus 3, some students will notice that each one of these start with x and x in the parentheses. And that is true for these types of problems. So we have x plus or minus a number, and then x plus or minus a number. For all of these easy trinomials, you're going to always have x and x in the fronts of your parentheses, or maybe y and y depending on the variables. And then the other thing that they might notice is that there's always numbers back here. Okay? So if we're trying to connect our original problems to our final answers, then I want to go to the final answers and see if you can find any patterns there. Often my students will say, well look, the first one is always x squared, and that is true. So this first one's always going to be x squared in these easy trinomials with leading coefficient of 1. Another thing that my students will see is they'll look at the last term. We probably should include the sign there as well. And someone will look at that, and they'll look at the numbers that we issued in the beginning, and they will notice that 2 times 3, positive 2 times a positive 3, turned out to be a positive 6. So in our trinomial here, the last term, which was always a number, turns out to be the product of the two numbers in the original problem. So let's just check it. 2 times 3, is that positive 6? Yes. Positive 5 times positive 7, is that positive 35? Yeah, that works. Does it even work with negatives? Negative 9 times positive 4, is that negative 36? It sure does, okay? And someone will often say, well, this is always going to be some number with no x. It's a constant term, okay? And then the last thing students will point out to me is that this middle number is always with some x. So it'll be some number with a coefficient with some x, okay? But what is about that number? If you see the colored in purple, if you take the numbers 2 and 3, and this time if we add them, we get 5. So we will call this the sum, okay? So if I add 2 plus 3, that gets me 5. If I add 5 plus 7, that gets me positive 12. If I add negative 9 plus 4, that will give me a negative 5. So that middle number is always the sum, and the last number is always the product. Just as a reminder, the product means that they're being multiplied, and the sum means that they're being added. Okay? So now that we've seen those patterns, what I want you to do is use those patterns to work backwards to factor easy trinomials with leading coefficient of 1. The instructions say, factor the following trinomials with leading coefficient of 1. Be sure to factor any GCF if necessary. Well, in the first problem, there is no GCF in this problem, so we're going to go ahead and go straight to solving. Because this is a leading coefficient of 1, I know that my answer will have x's in both fronts, because that's what our patterns told us. The other patterns that we noticed is that the two numbers here in my solution need to multiply to 56, yet at the same time add to 15. So if you can do that in your head, great. If you know the two numbers, great. But there is going to be someone in the crowd that may not be able to do that in their head, or at some point your numbers will get too big and you just can't do it in your head. So what I'm going to do is I'm going to show you a way that you can find all of the multiples of 56 pretty quickly and see which two multiples will add to 15. So I'm going to start with 1. I always start with 1. And I list all the factors of 56. 1 times 56. Then I just walk up to 2. 2 times what is 56? And that answer is 28. Then I walk up one more. 3 times, well, 56 is not divisible by 3, so I just go ahead and cross it out. Or sometimes I just don't write it. Then I keep walking up to 4. 4 times 14. 5, 5 is not divisible by 56. 6. 6 isn't divisible by 56 either. And then 7 times 8. And then walk up one more 8. Well, actually, I don't need to include 8 because 8 is already in my list. So once I found a number that's already in my list, I know that I've got them all. There's only 1, 2, 3, 4 unique factors of 56. So now that I have those 5 factors, what you want to do is look through your list and decide which two factors will add to a positive 15. Well, in this case, it's the 7 and the 8. So I'm going to come in here and put plus 7 and plus 8, and that is my factorization. If you want to check your work with factoring, you can always check your work by distributing if you want to. You do not have to. This is an optional check. I'll show it to you probably just this once, and then you can do the others on your own if you want to. When I add the two middle terms, oh, look at that. It does turn out to be the original problem. So this truly is the factorization. Can this first one factor anymore? Nope, that's done. Can the second one factor anymore? Nope, that's done. So I have now completely factored this trinomial. In this problem, we have some negatives, so we'll have to deal with that. Notice we have a leading coefficient of 1. So this is what I call my skeleton answer. I know I have two binomial factors, and I know each of the first terms are going to be x and x. I need to find two numbers that multiply to 32 and at the same time add to negative 12. So I have 32, 1 times 32, 2 times 16, 3 doesn't work, 4 times 8, 5 doesn't work, 6 doesn't work, 7 doesn't work, and 8's in my list. Okay, so now I have all of the factors of 32, and I need to find which two factors also add to negative 12. Well, negative 12 is a kind of a difficult thing because we have positive things here. So one thing we need to talk about is how to multiply to a positive number. You can either take a positive number times a positive number to get a positive number, or if you use a negative times a negative, you will also get a positive number. So because this needs to add to a negative 12, I know that all of my terms have to be negative. So which two factors are going to add to negative 12 now? Well, the answer is minus 4 and minus 8. You can check if you have the time. So our third problem, again, we have a leading coefficient of 1. So I know my answer is going to have two binomial answers. I know my leading term is going to be x and x. I'm going to go ahead and put that in there right now. And I need to work on 40. Now this one's a little bit different because we have a y squared in the back and an x squared in the front. And in the middle term we have an xy. Well, notice that my x terms are going down nice and neatly. I have an x squared and I have an x, and then I have no x's, right? Just a number. Well, similarly, my y's are going up nice and neatly. So I have no y's on the first one y on the second one, and two y's on the third term. So because my x's are going down nice and neat in a pattern, my y's are going up nice and neat in a pattern, I know that I can still factor this. I just need to put y's in the back because y times y is going to get me the y squared that I want for my last term, and the two middle terms will have xy. So really, again, I'm only focusing on that negative 40. So my factors of 40 are 1 times 40, 2 times 20, 3, nope, 3 doesn't work, 4 times 10, 5 times 8, 6 doesn't work, 7 doesn't work, and 8 is in my list. Okay, so there's 4 unique factors of 40. But I need to multiply to a negative 40. How do I multiply to a negative number? Well, there's only one way to multiply to a negative number. That's one positive and one negative. So I need one positive and one negative, and I need to add to 3 at the same time that I need to multiply to negative 40. So we have the list that multiply to negative 40. Which one adds to a positive 3? Well, with one of each sign, it's going to be the 8 and the 5. To get that to be a positive 3, it's going to have to be a positive on the 8 with a negative on the 5. So we have x minus 5y and x plus 8y, and that is my answer. That can't be factored any further, so that is my complete factorization.